All right, ladies and gentlemen, welcome to the Ultimate Product Development Guide. So this is a poster with a list of 17 cards that we at Bevel Edge have developed to help our clients understand the development process of a new product. Now, keep in mind this is a practical application of it. So this is kind of some of the steps that we go through, and realistically, any seasoned senior engineer or staff or principal engineer could probably juggle 4 or 5 of these in their head at the same time, since they're working on 4 or 5 different products at the same time. That is kind of like the expectation. Now, if you are someone who has their own online store where you're selling, new products, things that such as consumer end products, all the way up to B2B equipment. This is kind of like a guide that will ultimately help you move towards the right direction and make sure you check off all the boxes and have all the information from a top level view, so there aren't any surprises, and help you through the product in general much better than you would if you're just trying to stumble upon these things for the first time when you're halfway through them. Part of the motivation to create this was also to help educate our customers. So our customers are passionate about designing their product and bringing it to market and making, a product that makes a difference and brings in a lot of revenue. And our success at the end of the day is to help support them with that. And in order for them to be successful, it only made sense that we're all on the same page and kind of understand the same blueprint and know the same things to expect. So when we're saying X, Y, and Z, it is interpreted in the same language from both parties. Now, other people who could benefit from this presentation and this ultimate product guide at the end of the day are junior engineers, people who are going into the product development industry. So a lot of times these are mechanical, electrical, software engineers that are just now graduating and going into the real world. And, some of these things are not taught well in school, or, if they are taught well, they're taught in congruence with hard skills that, sometimes make these classes seem kind of like easy breezy classes. But when you get to a big company in the real world, this is kind of the differentiator between a good or a great engineer, is whether they understand this. Now, project managers and of course, product managers should also have a good understanding of this, since they're going to be the high-level people who are in charge of making sure a product moves forward. Okay, so now let's actually look at this poster. By the way, this poster is, again, free to download on our website. Go ahead and download the PDF. That way you have it permanently and can use this guide moving forward. Okay, and here at the top, we have the legend. Let's look through that. General in black, design and engineering is in blue. So you see developing a new product is pretty blue heavy, so design and engineering heavy. Of course, there's a huge amount of marketing involved as well. Those are in green, and also the legal cards that you see here. So legal for product launch is mostly compliance and actually patentability and patenting these things. So those are things you should kind of expect. And of course, in yellow are gate reviews, and gate reviews are essentially just official meetings between client and customer, getting together, putting their heads together, looking at the documentation and what's available, and pulling the trigger and moving forward into the next steps. And big companies also do these gate reviews where they have maybe 40, 50 different kind of stakeholders all in that meeting paying attention to see which direction a product will move to. So and this entire thing is chronologically ordered, so chronologically loosely ordered. So you go from 1 to 17, and you got these arrows kind of helping guide you through these cards, and bullet points on each, and kind of like what the top level expectations and the subject matter of the card is. So hopefully this will be a help to you. Okay, with all of that, let's get started into looking at the top 5 cards here at the top. So cards 1 through 5 are split up into kind of like market research and market development. So this is kind of what we follow. And I guess right now is a good time to mention this book here on the right. It's called Engineering Design by George Dieter and Linda Schmidt. So this is an official academic approach to how product development is done. So these guys have written an excellent book teaching engineers and other people how product engineering design is done, and kind of what the steps are and what to expect. And these graphs that you see here come directly from this book. So in this book there's hundreds and hundreds of pages. We've condensed this entire thing to one poster essentially. So if you want more detail, I highly recommend reading this book. One of the points of advice that I give to project managers, new product managers, is, hey, go read the first 3 chapters of this book. And if you understand the first 3 chapters of this book, you are going to be successful at the beginning of your career. If this is something you're going to try to learn the long way around, you're going to pay for it. And this also goes to people trying to launch our products, right? Which is a lot of this motivation behind creating this ultimate product guide. So the book Engineering Design has our 17 steps here, kind of following the same path. Now we've taken the first 2, the define the problem, gather the information, split up into 5 different cards. They have just split it up into 2. And if you are looking at figure 1 of this book, you can see that we're here in the highlighted red section. It's called market development. And before we move further, it is worth taking a second and looking a little bit more detailed look at this graph and what it means, because you as someone who's trying to develop a product or launch one for the first time, it is critical that you understand this, and so you know what you're getting into. Kind of help adjust expectations. Okay. So there is a minimum amount of money or resources and time needed to launch a product, right? This is, I'm drawing this line here. That's the minimum amount of effort required. And in the book, there are 2 different paths that are highlighted to get to this, right? So some of the big companies, such as, let's say, Toyota, Honda, Boeing, Airbus, they have the luxury of spending a lot of time and a lot of money and resources upfront just doing market development and conceptual designs, right? So they spend a lot of money upfront, and then once they feel comfortable, they'll pull the trigger and bring the design team in, and the design team really quickly, with expected amount of effort, completes that design, and then they move into the production stage and start manufacturing it with very little surprises. So what they do is they spend a lot of time here in the first 2 quadrants doing their research. And now there are other companies, due to different market states and motivations that they have. What they do is they briefly move towards these conceptual stages real quickly, spend some time designing it, and inevitably they end up with surprises and high manufacturing costs before they ultimately reach that same spot. So it might seem like you're doing really, really well. If you're not aware of this, you get to this point and then you get your first quote from the manufacturer, and holy smoke, this entire project is not even worth pursuing because it's too expensive. So we do help our clients anticipate some of these things, and kind of part of the motivation of making this ultimate product guide is to help bring them all on the same page. Now, how does Bevel Edge approach this? I guess it would be worth mentioning here as well. So what we try to do is spend a decent amount of time doing research and development, market research and conceptual design. And realistically, our customers can't afford to take 2-3 years just researching and conceptualizing products, right? They want to move quickly. So we try to get that done in a few months at most, right? And then what we do is we spend most of our time in the actual product design. So we, since we are at the end of the day an engineering firm and we help people design and move things forward, our biggest value proposition is the engineering design. So once we help them design that, we'll help them with the manufacturing, and hopefully there aren't any surprises during the manufacturing process, since we did our due diligence, most of it during the product design stage. So this is something to keep in mind as we move forward with the next slides in this presentation. All right, let's move to card number 1, product idea. So the best product ideas come from people that have extensive market experience or are market participants in a given industry, know the ins and outs, and have gotten the full experience of what the market does and what the products are that they could possibly come up with. And here are listed some of the demographics of the best products and the best kind of people that can come up with possible ideas. At the top you have an electrician who's worked in different facilities and has found some problems that he can solve. Maybe someone who works in construction who can come up with a new product that every single home will need. Maybe a teacher who can come up with a new toy that can help kids learn. Someone here in the bottom right, a mechanic, for example, that has worked on cars for many, many years and finally comes up with a new kind of screwdriver that is more comfortable and will revolutionize, and essentially these products will fly off the shelf. And in the bottom left are dear athletes, so people who have been participating in a sports for decades and have dedicated their lives to it. These guys are runners. Let's say one of them comes up with a new shoe that makes you 1% faster or makes you 10% more comfortable when you're running, allowing you to get multiple reps in where you otherwise would have just had to stop running from foot pain. These guys are the ultimate people who can come up with these products. Now, we at Bevel Edge, we don't come up with new products. We help people move their products from concept to actual full-on production. And that is kind of where the actual idea starts. We just help people move towards that. And if you are one of these people, you have a lot of market insight and you have participated in an industry for an extensive amount of time, and you see something is there that could be turned into a product and could have an ample amount of customers right away, you would fall into one of these categories of a person that can come up with the product idea. So one other thing is that the person needs to have an adequate amount of motivation and resources, right? So if you have zero money and if you're not motivated to launch a product, essentially the idea goes poof, and that will be the end of it, and we'll never hear anything about it, and the world will be worse off for it. So at the end of the day, product ideas come from the right people, and we vet our clients appropriately to see if they are the right kind of partner for us, and we want to ultimately want them to be successful. And if we're not the right firm for them, we'll refer them to someone else. And if they're not the right client for us, we'll refer them to someone else and wish them the best of luck. Okay, project kickoff. So that is actually where kind of the rubber meets the road. That's when you actually decide to get on the long road to launch a product, and you dedicate yourself to the time and effort and resources that is taken to go onto this bumpy road and make this happen. Kind of project kickoff, I guess you could consider this as an initial consulting where a client will come to Bevel Edge and say, hey, I have XYZ product. Of course, we'll hear them out for an entire hour, completely for free, no strings attached. Put together a project budget, tentative project timelines, and kind of some of the project responsibilities are reiterated to the client, as in like what they need to do to make this project successful and what we will do as part of our responsibility to help move the project forward. Okay, starting now or moving on to the product research stage. So that is card number 3. Product research is basically the due diligence you need to do before you pull the trigger, spend more money and effort on developing a project. And it's split up into half marketing, half engineering, or half design and half marketing, made out of 4 different points. I'll go through them. Preliminary market research, kind of putting the fundamentals, technicals, and market dynamics together. Number 3.2, conducting a benchmark study, seeing what already exists out there. 3.3, customer market analysis. So who are the customers? Who's going to buy this product at the end of the day? If you don't know that, or maybe you have a misconception of that, it's worth looking into. And then a house of quality, which basically is a 1-page assessment of what is important for this product. Going back to the engineering design book and their handy dandy references, looking at figure 1.5, this is something that you need to accept as reality moving into your first product design. Is at the beginning, your knowledge about the problem is limited. So it is, let's say, very minimal, put a dot right here. However, because your information is limited, you think there are many, many possibilities of making a successful product. And what happens is, as you increase your knowledge over time, so let's say you do a market study, you do your benchmark study, you do your customer research, you do your house of quality, and you start designing the product, you kind of increase your knowledge, you end up somewhere here. And as your knowledge increases, you realize that your design freedoms kind of diminish. Whereas first you thought you could make this out of plastic, you could make it out of aluminum, you could make it bedazzled. The more you look into it, you realize it is more and more limited, or you could do those things and it'll be too expensive. When it's too expensive, no one wants to buy it. And then maybe you need to do a batch of 1,000 and you can't really prototype it. You need to move towards market quickly. So your design freedoms kind of diminish, right? And what happens here, basically what this is telling you is that your idea is going to converge to a singular, most optimized solution that can meet all of the requirements that you will figure out. So this is also something to keep in mind. Now, figure 1.4 of the engineering design book does a great idea, or shows a great illustration on how it is that these mistakes are made and could be avoided. So let's go through these 6 little trees and the swing. So the project sponsor, right? This is in our case, the client that comes to us and says, hey, I have XY idea. You know, the idea is like, I have a swing. It's the best swing in the world. 1, 2, 3 kids can sit on it. And it's 3 times as efficient as any swing, 3 times as fun for the kids. And I want to patent this. I already have a patent and I want to get this started. And then, sure, we do our market research, and the independent market research concludes, so this is these guys who are doing the market research. They conclude that parents, they interview the customers, which at the end of the day are the parents who are forking up the money to buy the swing. They say the parents want a swing that is safe for the kids, and in order to make it safe, we have 3 ropes instead of 2, because 3 ropes is more safe than 2 ropes, and the parents are going to buy this because that's what they want. Then they give those requirements to the design engineer, and they tell the design engineer, hey, design us a safe swing. And here's what the design engineer does. He says, oh, well, the trunk of the tree is the most robust part, so let's attach the ropes to the trunk of the tree. It will never move, it will never budge. And in the end, we'll just keep that loose so no one can jump on it, sit on it, and potentially fall off, get hurt. And that is the design engineer's interpretation of finding the ultimate product. Then the design packet gets handed over to manufacturing, and manufacturing looks at the problem and says, well, this design is kind of hard to make, but we have a workaround. We'll just connect the rope to the right side and this rope to the left side, and that way our constraint in manufacturing is easily solved because it's too hard to connect both ropes on one side of the tree. Now you end up with again a swing that is not usable. And then when the user gets it because the product is incomplete or due diligence was missing, and that's how they have to install it. So they go and they cut their tree down, support the tree, the cut off part of the tree with additional equipment or additional branches, just so they can have the swing back and forth. And this makes it expensive, costly, and destructive for the user to use. So they're saying this is how it's going to be. I don't want to buy it, right? So-and-so has bought this product, the swing already, and it ruined their backyard because their tree had to be cut. I don't want to buy it. Now, if you do your product research, over here you do your product research properly with the right amount of due diligence, you will come to the conclusion that that is what the user actually wants, right? That is what they want to spend their good hard-earned money on. And if you can provide them that, you'll capture the market. They never wanted a swing with a board that they could sit on. They always wanted a tire swing, right? So this product research step is critical in sending you into the right trajectory to where you can actually move in the right direction with your product and not follow your own idea necessarily or 100% or your own passions or what you think is best, but what the customer wants. I guess that's the customer's voice at the end of the day, what matters in terms of success of a product. Okay, let me start to break down 3.1 to 3.4 individually. Okay, preliminary market research. So, you're going to spend money, time, and effort on developing a product. And the question I have here for comparison is, if you're going to spend, let's say it costs you $20,000 to launch a product. And if you're going to spend this $20,000 in the stock market, what are some of the things you would do before buying the stock? Of course, you would look at the fundamentals of the market, right? So what's the geography? Does it make sense to start a boat company in the middle of the desert? No. what is the market size? Do I really want to, let's say, custom watches or really expensive watches? What's the market size? Do I really want to get in there? Is the pie big enough for me to grab a slice out of? Or is it not even worth it? So some of these questions kind of can obsolete a product idea right away. Next, market technicals. For example, who are the big players? Is it seasonal? Right? Big players are there big companies who have kind of the market cornered already? Seasonality. Let's say you come up with a great idea to maybe launch Christmas lights, right? New Christmas lights that you want to patent and launch. Well, guess what? The seasonality will play a big role in like when and how you should adjust your product and your market idea to. Okay, Christmas lights. Like, you're not going to be selling any of those in a Muslim country, right? They don't celebrate Christmas, for example, or a country that does not celebrate Christmas. So things will get limited, or things will change. And then market dynamics, right? How does the money flow? Who are the manufacturers that you have to deal with? Who are the resellers? Can you sell directly? I think, for example, when Tesla launched their car, they realized that they're forced to go through resellers, right? And they wanted to sell their vehicle directly to consumers. And, there was a law in place that for consumer protection, you have to buy the car not directly from the manufacturer, but through a reseller. And then also the retailers, like, are you going to be selling to retailers? Are you going to be directly to the market? And who are going to be your retailers? Can your product be sold in Walmart, Sam's Club, Target, right? You name it. So these are the basic 1, 2, 3s that you have to do in your preliminary market research to see if your idea is actually valuable and can produce quality results for you. Conducting benchmark study. Okay, so here's an example of a barbell collar. So this is basically a clamp that holds a given weight plate to a given barbell. And if you came up with an idea similar to it, like we've done in the past, or worked with one we've done in the past, you want to do a benchmark study. And when you do the benchmark study, basically what you do is you go on the market and you start buying all these different products that do the same exact thing, and compare the pros and cons and see why each one of these exists and what are some of the standards that your idea would need to meet in order to be satisfactory to the consumer. Okay, so let's go through each one of these individually. The one in the top left here, their value proposition is that they'll just fit on the bar, barely do the job, and they're extremely cheap to make. So the people who want these are actually gym owners. They can check off that, hey, we have barber clamps at our gym. Next. And then the ProLock number 1. This product here is, it prides itself that it works on different size collars, 50 millimeter and 1.9 inch IDs, right? So this works for 2 different versions, whereas this has a single size. This one also looks like it is a little bit more robust and cheap to manufacture. It has this liner on the inside, and this liner will protect your barbell sleeve. So that is its value proposition. And then here on the right, I think this one slides on really easy. You don't have to turn a knob or move a spring. It automatically locks into place, and that is its value proposition. And just looking at the first few, you're kind of getting an idea of like what you're really up against in this market. People want a robust, strong collar that's convenient and easy to put on. Here in the bottom left, there is a plastic version of it. So out of 1, 2, 3, 4, 5, 6, 7, only 2 of them are made out of plastic, right? For the most part. So those are things that will pop up to you as soon as you do benchmark. This one is just, super cheap and easy to install. Next, the ATX one. This one prides itself in being an exact weight, competition rated, and to be robustly strong. Like, I think neither one of these have an exact weight to them. They just weigh as much as they need to, but this one has an exact weight of 2.5 kilograms, and that is their claim to fame, and that's how they start making their sales, because they can guarantee that to their customers. Now, these clamps here in the bottom right, if you do your benchmark study, essentially buy each one of these and compare them. These guys have the best performance, physical performance, so strength to weight ratio. So basically, they can hold the most amount of weight while still being the lightest. And some people are interested in that, and this is essentially the market that barbell collars exist in. And if you're going to come up with your own, you need to compare your competition, do a benchmark study. Next is customer research and market analysis. So here you want to answer a few questions here. Who are the customers? What is important to them? What is their demographic? What is their budget? How do they use this product? So if you are building a product, let's say for kids, like a kid's toy, you need to understand that it's essentially mommy and daddy that are buying this product off the shelf. So who are you really marketing to? Are you marketing to the kids? If you have a product that you are trying to market to, let's say, a grandma, what do grandmas do? Like knitting sweaters. You're not going to market and advertise it as you would to a young male who is interested in, let's say, sports cars, or maybe more aggressive and more exciting products. So understanding who your customer is, what they want, and what they want to pay for is something that you should do up front before even getting started with spending more money and effort in the design. And at the end of the day, understanding your customer will help you understand your product requirements much, much better. And that's really where they came from. Where these product requirements come from is from the customers. For customer research and market analysis, what we do is we phone 100 different people and ask them about a given product. And this is done manually. We sit on the phone with each one of them for 5 minutes at a time and ask them questions and see what they think. And, if you have a sample of 100, you can get a decent poll of what people are interested in. Okay, looking at the house of quality next, step 3.4. Basically, house of quality is a quality function deployment. Also in detail discussed in engineering design, talks about what the voice of the customer is and how you can optimize what the customer wants. So an example of the house of quality, I think this is the most complete house of quality that they have here on the right. Room number 1 are the customer requirements. So what you do is you list those requirements out. Room number 2 are the things that are in your control. So you're in control of the design, actually, like weight, size, color, material. And this is what the customer wants. They want something that's sleek. They want something that's light. They want something that's robust. So you list those out. And you correlate them to each other. So they will all come together and create a point. Right? All these creates different points. And you can correlate these points together and come with a conclusion of which one of the things you're in control of is most important and how you can influence the design to where the customer looks at it favorably. And now, one of the graphs here, figure 3.5, is the Kano diagram, also discussed in engineering design. So this is in the back of every engineer or good engineer's mind, and they can balance these things. Let's go through these 4 different points here on the line. So on the x-axis, we have something that is either absent in the design, so not included, or fully implemented. So that means it is full-on effort was spent in putting it into the design. In the bottom, on the y-axis, we have a dissatisfied customer. So they're like, man, this product sucks. Or a highly satisfied customer, like, man, this is the bee's knees. And some requirements that you have in control of are the exciters. So let's do an autonomous driving car, for example, a car that drives itself. Now, what is an exciter here that falls under line number 3 is that the car can actually drive itself and has the proper software. So you see, with a little bit of effort, right, as you move over this threshold, with a little bit of effort, you can get huge amount of satisfaction out of the client. So maybe it's not the most perfectly safe self-driving car. Maybe it can't drive off-road. It can not drive on highways, but at least it can drive on its own in the city. And that is pretty satisfactory to the customer. And they're like, you know what? I'm going to have to buy this. So with a little bit of effort, you get a delighted customer. Now, some parts of a self-driving car are performance related and they're linear. So how fast is the car, for example? The more horsepower the car has, the faster it has, the better mileage it has, that falls on the performance line. So if the car sucks in gas mileage, or if the car is super slow, you're going to have a disgusted customer. But the more time and effort you spend on this, the linear is the result and output. So once you design this car, if you spend more time and effort in making the autonomy nice, you'll get more out of it. So it certainly makes sense to spend a lot of effort on point number 2, and maybe a decent amount of effort on point number 3. Mind you, point number 3 has diminishing returns, right? So there is only a limited amount that you could work on. Like, you can't make the autonomy better than fully autonomous. Like, if it's autonomous, it's autonomous. It doesn't make sense to spend more time on it. It does what it's supposed to do already, and the customer is excited. Performance, obviously, the car can continuously go faster and have better gas mileage, and it always makes sense to continuously work towards it. And then there are things on the must-haves, right? So nice-to-haves, must-haves, exciters. And for example, what would fall in under line number 1 is corrosion resistance. So people don't want a car that rusts. And naturally, you have to put a decent amount of effort to bring this graph up, because up here is where the customers are happy. But just know, no matter how much time and effort and money you spend on corrosion resistance, it's not going to be a wow factor. That's going to be like a basic minimum requirement that the customer has expectations of. Like, you've never gone into a car lot and were like, I want to buy the most corrosion resistant vehicle you have. That's not on people's mind. So people really care about the exciters and the performance aspects of a product. And now, if you don't meet the basic expectations, boom, really, really quickly, right? As soon as you buy this new Porsche, this new elegant car, and it starts to rust, you will quickly drop and have a disgusted customer. So this needs to be brought up to an adequate threshold that you'll find through your market study and your benchmark studies, and you must keep that. But it doesn't make sense to spend a lot of time and effort on it. So there's something to keep in mind. And then there are things that the customer are indifferent on, and everyone has a different opinion. Like, for example, the color of the car. That's indifferent. Some people like the color black, some people like orange, some people like blue cars, and some people want their sports cars to be red. So that kind of falls under indifferent, or maybe they don't care at all whatsoever. So those are, 4 different points that you need to be able to juggle in your head. And I'll later make an entire video about the house of quality, teaching you guys how you can utilize it and what it means to be a product champion and spend time and effort on certain design aspects of a product to make it successful. Okay, moving into number 4, and that is the patentability search. So, you've done your market research, and you found out what it takes to have a first-class product, and you're about to pull the trigger. And the voice in the back of your head says, well, what if someone else has that patent already? And just because that product doesn't exist in a market doesn't mean the patent doesn't exist. So there is a handful of patents who've just been patented for the sake of it, or the product launch was not successful, and that patent exists in the US Patent Office, and it's never going to be implemented. However, someone else owns the rights to it. There are people who intentionally just patent things randomly or focus on a specific market to patent them, and wait for someone like you to actually launch a product, and then they raise their hand and say, hey, guess what? You're infringing on my patents. Those guys are called patent trolls, and it's like an entire industry, and it's sad that these things happen, but one way you can protect yourself from this is do a patent landscape study. And basically what we do is we for the client, we go through the U.S. Patent Office and the list of patents and do maybe, let's say, academic research and do a decent amount of due diligence to see the idea that they have, is that patentable, first of all? And if there are patents that exist, what do they look like? Who owns these patents? And with this insight, we will gain more confidence, or we gain more insight into developing the product in the right direction. So let's say there are patents that are very, very similar to what the client has as their idea. And if we do a patentability research, then we know what already exists. So what we can do is adjust the design and adjust the claims and the technicals of the product such that it does not infringe on previously existing patents. Now, on the flip side of that, once we do the patent search and we find a gap, let's say everyone has patented X, Y, and Z, but W, no one has ever thought about that. Let's take advantage of that. Let's bake that into the design. That way we can patent it in the future. because it has utility and no one has thought of it before, or at least no one has patented before. So that is the value proposition here of doing a patent research or patentability search, finding the landscape, who owns the patents, avoid infringing on existing patents, and then define patentability gaps. So this is step number 4, and we highly encourage customers or our customers to move into that direction, do the patentability search, because one thing you want to avoid is being surprised. Oh, guess what? The idea that you spent all this money, time, and effort on is not patentable. Someone else has the patent. And, there goes the end of it. Now you're getting into a legal dispute. So, or conversely, if you do the search, like I was saying earlier, you find a gap and you're confident that your product is patentable and that you have a space in the patentability landscape, and that gives you additional confidence and strength to move forward, let alone it also adds utility and value to your project. So some of the products that exist out there are not patentable. Let's say like a bolt or a screw. It's going to be really, really hard to design a new screw, a new bolt that works better or is patentable. That's just considered common knowledge. So those things don't really need to have a patent, and all you have to do is focus on maybe manufacturing and price and quality. And some of the things that you will come up with must have a patent in order to protect you, because at the end of the day, the quality doesn't exist because the product doesn't exist or the concept doesn't exist, and your only chance to make money and beat the market and secure yourself is through a patent. So the patentability research has a lot of utility to it, and we certainly recommend our clients to move forward with the patentability search before we get started with further down the road on project development. The next step number 5, is to actually get together, sit down with the client and review all of the research that we've done, the patentability research, the product study, the market study, and put our heads together and decide, do we want to go or no go? Is it make sense to continue, or what is actually the strategy that we want to go towards? And the best way to do that is to have a criteria review meeting, a CRM. Basically, that is getting together and listing out the requirements of the product and quantifying the requirements of the product. Like, how tall does it need to be? How much does it need to weigh at maximum, at minimum? How strong does it need to be? And does it need to fit in a given box for shipping? If it's a box that's too big, it's going to cost more for shipping. Does it need to be made out of certain materials? For example, does it have to be a soft material? Does it have to be a brittle material? So all of those things are part of the criteria review meeting, and that will ultimately help shape the requirements and concepts moving forward for the design. So it's important to have this meeting early on and get buy-off, and so everyone is on the same page. Okay. Moving on to steps 6 and 7. So this is actually in the book Engineering Design, split into 2 sections. Concept generation and evaluation of concepts. So concept generation and evaluation of concepts are split up into 2 sections here for us as well. And that is when you finally get down to this section of the product graph. So if you're looking here in the bottom right, in the highlighted section in red, you've done your market development research, and now you're actually creating the concept. So based off the requirements, based off the customers say, based off the idea that you have, what is something that's actually totally worth spending the time, money, and effort in? And in order to decide that, we need to have a proper concept. So let's move on to the step number 6, or card number 6. Okay, this is a given pull-up bar. We've done a pull-up bar for a client here in the past. And what is a conceptual design that you might ask? And here's an example for the pull-up bar. So a conceptual design is, needs to be done fast, low cost, super cheap, as easy as just maybe a PowerPoint presentation or some sketches, where you get together and you draw something up that can kind of get the gist idea of the product across. So here in the top right, you can see a pull-up bar that has multiple grips, allows multiple exercises. Here in the center, you have some kind of embodiment of what the design should look like, what the person should think, and now this is actually someone using it. And what you want to do is you want to do some of the fundamental calculations and identify technical risks. So this will help you with the magnitude of the problem. So does the pull-up bar tubing need to be made out of aluminum? Can it be made out of steel, or does it have to be made out of titanium, for example? And this will just depend on how strong it needs to be, and you won't know that unless you do the fundamental calculations and put some equations together. When you start doing that, you can start identifying technical risks and schedule risks. For example, you come to the conclusion that in order to make a pull-up bar, the material needs to be strong enough to where it can hold an adult person of, let's say, 100 kilos. But it also needs to be soft enough to where you can bend it without it breaking. So you need an aluminum tube or a metal tube that you can bend. However, that material needs to be strong enough to resist the loads of operation. And if, let's say, such a material is not easily sourced, then it becomes a schedule risk. So now you're risking, when you go to production, that this material is not going to be found, or it's too expensive. Right now it becomes a financial risk. Or let's just say this configuration is kind of dangerous. It's hard to find a material that can bend into shape and also be strong enough. So now it becomes a technical risk. So those are the things that you want to kind of hash out. All right, moving on to the conceptual design meeting, the CDM. Now you have your concept, and you are trying to put the effort and money and time into making that actual design come true. So what you do here, you host a meeting and get the people who are interested in this product moved in the right direction. You assess the technical risk and the schedule risk that you picked out in your concept, and get everyone's buy-in. Now, I have been a part of companies, big companies, like giant corporations and small startups, and the vibe is either two ways, right? Either you're sitting in a room and everyone knows exactly what they want to move towards, and oftentimes it's just whatever the executive branch, like let's say the executives, like the CEO, the CFO, or the CTO want to do, and everyone's just there out of formality, and we're just going to do what the big boss wants anyways. Or it ends up being something like, hey, none of us have a clue if this is even going to freaking work, but however, we're all in this together, and we'll approve and back each other up as we spend the money, time, and effort towards this project. So for us at Bevel Edge, we want to make sure that our customer feels comfortable with the concept, and that we feel comfortable that we can deliver the concept before we move forward. Hence the importance of a meeting as a conceptual design meeting review. So, all right, so now things start to get more fun and more exciting, and that is the prototype design stage. And before we look at card number 8, let's look here in the bottom. The engineering design book has that split up into 3 different sections. So product architecture, configuration design, and parametric design. So that is kind of how to interpret step number 8. For us, step number 8 is 1, 2, 3 different subcards in here. And that is in the highlighted section. Now you're actually moving towards a product design. This is actually where you're spending the money and time and creating, the design information here, basically. That's how you are developing the product. So you're spending time here in the previous, coming up with concepts and learning about the product, and here's actually where you're building what the concept is and what the original idea was. So if you go back to slide number 1, that is what you've always wanted, and hopefully based on the research, what you've come up with is the right thing. Okay, product design is split into, or prototype design, is split into 2 sections, 8.1 and 8.2. 8.1 is the product definition. So that is CAD models, so 3D models that you will use to convey and evaluate the parts and assemblies, and that is something you will give to your manufacturer so they can make those parts and assemblies based off your CAD models. And then you also make prototype drawings. Prototype drawings capture information that the CAD model simply cannot. For example, a CAD model can give you an exact geometry, but it doesn't give you the tolerances. So, if you go to someone and you ask them, hey, I want to make a tile for the floor, and it has to be 1 foot by 1 foot in size, and you give them a perfect CAD model, what ends up happening, and when it comes out in reality, it's not going to be 1 foot by 1 foot. It is going to have slight deviations, and the corners are going to be perfect. So here in the engineering drawing or the prototype drawing, you have a chance to kind of define the deviations from the ideal CAD model that are acceptable. And then prototype bill of materials. So a bill of materials is essentially a document that ties all the product requirements and product definitions together. And some of the things that you can list in a bill of materials is maybe like specifications, standards, and processes that the manufacturer should follow to make your design happen. So this is kind of, I don't want to say it's public facing, but this is something you share with your vendors or your manufacturers. Now, production design documents or prototype design documents. Design documents here on 8.2 are proprietary. You keep that close to your chest, and the only time these things will see the sun of light is if you're in a lawsuit. So these are the fundamental calculations, your engineering simulations. Right? So we'll talk more about those in detail. And then before we actually send the quote to spend money on the prototype hardware, what we want to do is have a prototype review. So sit together with the clients and see if what the client was expecting, if that's the prototype they want to move forward with, get approval, and then pull the trigger. And of course, the whole point of card number 8 is to have prototype hardware in hand, and that will be ultimately used for testing. So we want to get the approval and have a discussion with them before we move to the next step. So here is an example of a prototype design packet. Again, if you want to create a piston cylinder system, and here are some examples of the CAD models and the drawings and some of the things you should expect out of a prototype design packet. This is basically a communication between you and the manufacturer or the vendor who's going to make your prototype on what the product needs to be. You don't want to leave things up to interpretation. You want to be as specific as possible. But the reason why this is prototype is because things are not fully clear to you or they're not fully finalized. So that's kind of like the whole point of this. And then going back to the design documents. So here, for example, are some engineering simulations that are part of the prototype design documentation or design documentation. Here is a rotor disc hitting the brakes, and the evaluation here is a thermal evaluation, like how hot does it need to get, how hot was it get. And in order to do this computer simulation, you need to have some kind of inputs, right? Computers and calculators tend to be garbage in, garbage out. However, if you can provide the correct inputs, the simulation that you get will make sense. Now, in this case, we want to know like how big is the vehicle, how much does it weigh, and how fast is it going to go. And based off of that input, you can create a simulation that can properly recreate how much heat is created in these brakes, and that will ultimately guide you in the material choice that you need to create for this brake system, right? So the fundamental calculations of physics will lead you to inputs for your system. Here on the bottom left, we have a skateboard, right? That's simpler. That's maybe a static equivalent model. And then here is a dynamic model. So you'll simulate the golf swing based off a fundamental calculation, and you'll see if the simulation matches that. This is kind of like a dynamic simulation, so things aren't just in colors, they're actually moving in the screen as well. And on the right is a blow dryer, and that is maybe thermal and fluids. So how will the fluid move? How are the thermals of it? Like, is it going to be too hot? How much electric power do you need to get an output of a certain temperature at a certain flow? Maybe that's not realistic, or maybe it's going to burn a person. So these simulations, again, the prototype design documentation, like engineering simulations and fundamental calculations, are things you keep close to your chest, and they will only see the light of day during a lawsuit or a litigation. Now, if you don't have these, too bad, too sad. You're going to have a hard time defending your product. But if you do have these and you say, hey, this is the due diligence we did, and this is why we thought the product was safe, you're going to have a better time coming out of a potential litigation in the future. Okay. And then the prototype review and ultimate hardware. So why do we have a prototype review? Now, I can tell you from personal experience, I've been burnt with this and lost credibility with clients in the past, or lost face at a company that I used to work for with my first prototype showing up. What happens a lot of times is the conceptual design is going to be like the car here in the top left. Is the concept is like super cool. But you as an engineer or someone who's designed the product, all the cosmetic stuff is much of an easier problem to solve than, let's say, the suspension system. So the prototype you design is essentially designed to simulate the suspension system, because that is the most important thing about the product, and that is what you choose to prototype. You don't want to spend more time and effort making it look good, because if that doesn't work, you need to pivot anyways, and you'll just be wasting money and effort building a prototype that this is this good looking when you're not even sure it's going to work. So I have delivered prototypes like this to a client, and their initial reaction was, oh man, you guys at Bevel Edge have no idea what you're talking about, or you particularly as the specific engineer is like bad at this, and they was like, hey, give me someone else, this looks like garbage, when they are completely missing the point of the prototype and what the actual reasoning behind prototyping is. And sometimes looks is a huge part of prototyping, but a lot of times you're trying to do the tracer bullet approach, which is a picture here in the top right. A tracer bullet is a bullet that is super bright and leaves a trace of light until it hits its final destination. So over here you have some guys shooting or doing the sniping, and the question is, what trajectory should this gun be so you can hit your target? And what you do is you kind of aim it in the right direction. You pull the trigger and a tracer bullet comes out and it gives you the trace of the path, and now that you see that, you can adjust and hit the target properly. Without the tracer bullet, you would just be shooting a bunch of times, guessing what you would hit, but a tracer bullet will make the current trajectory that you have obvious, and it will allow you to adjust with a given reference point. So a lot of times the point of this prototyping is to get a tracer bullet approach and get a reference point that we can build on or iterate on, or maybe something quickly that we need to see. So going back to why the prototype review is important with the client, because a lot of times clients will just see this and be like, oh, this is what you're giving me. No, you're not the right consultant for me. I wanted a nice product. You're giving me this. This is BS. So it's good to have a client and yourself on the same page when you're going towards prototyping stage, and understanding the value and the expectation of the prototype before the prototype hardware actually lands. Now, side note, prototyping and all this design approach that we've done until now has been on the left side of the V here. Now this is the system engineering verification V, the flying V, and I should probably take a second to explain this to you guys. On the top left you have the user requirements. We talked about that, right? What does the product need to be? And then here they have system level requirements, like how does the product need to perform ultimately as a complete package. Subsystem requirements, how do each individual component of the design need to perform, like how strong do the nuts and bolts need to be, how tight do they need to be. And then the component detailed design is what is the actual engineering drawing need to say for the design to be appropriate or meet requirements. So all of those things get funneled down until you have your software, hardware development, and integration. So that is what we're doing. We're actually designing the thing, and now that you have your prototype, you're here. And the question is, all the stuff that you've designed, how do you make sure that was the correct thing? And that happens to verification and validation stage. So here you're defining and creating the problem, and here you have to verify it. So system engineers specialize in finding tools and solutions and systems to ensure that each one of these steps can be done correctly. And once the steps have been created and a prototype has landed, they will help you with ensuring that these steps you've created were done correctly. So we've designed X, Y, and Z, and how do we know X, Y, and Z actually meets customer requirements? So system validation, system verification, subsystem verification, and component level testing and component level verification. So here we'll test individual components. Here we'll see how the subassembly fits together and maybe how the bolts were picked and how they interact with the material. Here we put the entire assembly together and put it to use. And here we give the product into the customer's hands and have the customer use it and get their approval, because that's the entire point of the concept, was to have customer approval. So anyways, that is the flying V. It's just a side note that, something to keep in mind. And which naturally leads to testing campaign. So here's that verification, validation, system engineering V here at the top for reference. And so what we'll do is we'll test the product, right? We'll create a test procedure. test fixtures. So like, look at this thing. This is a giant test fixture designed to test jet engines. Now imagine this has its own entire design cycle and design requirements. And when they're testing it, they'll follow a test procedure. And then obviously this is a giant test fixture we just talked about. Test equipment. So what are the sensors that you need for testing? What computers you need? Cable routing that you need for testing, right? And then a test report when the testing is complete. How do you put that together and present it? And the test report ultimately will defend you in case of litigation in the future. And then validation and certification testing is we'll give it to the customer to use, get their opinion, right? Do a soft launch and get people's ideas on it. And certification testing, if, for example, you have an electronic component and there's a governing body that determines how safe electronic components need to be, we're forced to conduct a testing based off that certification and get your product a certification. Now, aerospace companies and car companies are experts in this. Like, that's why the planes are so safe and the cars are safe. Like, you're never worried that your wheel is going to suddenly pop off, because the engineers and the companies have done their due diligence and followed the validation process specifically. And then once you do the testing, we'll get together and review the final test. Okay, moving on. Now, in this slide, I'm kind of giving you the relationship between step 8 and 9, the prototype design and the test campaign. So if you want to improve your prototype, you need to test it. And if you don't test it and don't measure it, you can't improve it. What happens here is there's going to be an iterative design where we test it and improve the prototype, go back and test it again, and modify the prototype again until we're happy enough with the performance, and then we push it on over to final production design. Here, production design, when you finally reach the production design process, that is, again, going back to the graph right here in the highlighted section, and specifically we're doing at the detailed design. So that is when we're ready to actually launch the product. It's very similar to the prototype design documentation. It's just more detailed and will serve at the end of the day to protect you as the product owner. So your production design packet, that is going to be civil litigation. So hey, I gave you X amount of money. So let's say you're going to launch your product and you give your manufacturer like $50,000 to get started with the first batch. And then they give you $50,000 worth of the wrong product. What you can do is defend yourself with your production design package and say, hey, look, here's the documents I gave you. They said X, Y, and Z, but you did not provide me that. It is different than what I gave you. So that's the whole point of the production design packet. It allows you to protect yourself from malicious manufacturers. In addition, a proper production design packet will become so valuable when you get ready to sell the product. And you got to keep in mind that maybe you are not going to be the only person that's going to produce this product. Maybe you'll sell the product to a bigger company or another investor who wants to continue making it. And if your production design packet is unclear and ambiguous, it reduces your value and it gives them more room for negotiation. So the product design documents, 11.2, those are going to be held close to your chest, extremely proprietary. No one should ever see these unless we go to court. Now, production design documents are there to save you in case something catastrophic goes wrong, and you can prove that you have done your due diligence and that the accident that happened should have never happened because you've done your due diligence here. So that's kind of the detailed design. So let's get into card number 11 in more detail. Okay, so the production design package has very similar elements to the prototype design package. You got your CAD model, this is a 3D version, and you have your 2D drawings that give you additional details and tolerances that's not captured in CAD. And then you might want to do some geometric dimensioning and tolerancing. This is the American Society of Mechanical Engineering's method of conveying. So it's essentially the language that manufacturers and designers speak to know what they actually mean and bring them on the same page. Because just looking at the 3D model, you don't know like how accurate it needs to be, and maybe the way you've dimensioned your dimensions on the drawing and the lines that you drew are maybe ambiguous. However, geometric dimensioning tolerancing is a universal approved language that helps reduce those errors and misinterpretations of the product. Now, bill of material. What does the bill of material do in a production design packet? The bill of material lays down specifications, standards, and processes that they need to follow. So even though you have a perfect design, if each individual bolt isn't tightened properly or using the proper lubrication is not done, it becomes a bad product and it can fail. So you don't want to leave those things up to ambiguity, and you want to fully define them, and you do that in your production bill of materials. And then assembly procedure, right? Assembly procedure, kind of same thing as production bill of materials, adds additional information that's beyond the 3D or the 2D sketches, beyond the standards. It's basically process. And assembly procedures can also be made for the customer. A lot of times when you're buying IKEA furniture, you have to build it yourself, and their assembly procedure is essentially what helps you and guarantees you that you build it together, and it saves you cost, saves the manufacturer costs. It's a win-win for everyone, but the assembly procedure needs to be correct. And then finally, product packaging and controls. So let's say you have the beautiful product, you have nice china, silverware, perfect CAD models, perfect drawings. The manufacturer is excellent and they do a good job, but their packaging sucks, and now the products break before they reach your inventory. Or worse, they start to stack too many boxes on top of each other. Now the boxes in the bottom get crushed under their weight, and the equipment starts to break. Those are product packaging controls that you need to put into place. And what you don't want to do is find out these surprises once it happens in the field. So you get your inventory and half of it is broken. Now it's between you and the manufacturer to say who's going to pay for these. Are you going to pay for some new ones, or is the manufacturer responsible because they packaged it incorrectly? So you want to be upfront with those requirements and make sure they're explicitly stated. And that's the whole point of the production design packet. And then back again to production design documents. The tolerance analysis is something new compared to the prototype. So you want to make sure that in worst case scenario, all the things fit together depending on the engineering tolerances that you've created. So one example is maybe a car jack. So the CAD model is perfect, but each individual nut and bolt might be different size. This arm might be a different length. And you just want to make sure that even at worst case scenario, like the worst possible design based off your design packet that you gave, that the product still works. That's the whole point of tolerance analysis. And of course, before we actually pull the trigger and move to production, we want to get together, step 11.3, have buy-off on everyone and make sure this is actually what we want to launch into the market. A lot of due diligence and peer review is needed here to make sure the customer is protected and the engineers are protected from any potential mistakes that have crept into the design, and reduce everyone's liability. So this is kind of a big deal, an important step, and an important meeting to follow. All right, let's say we have decided that this product is exactly what we want to launch, and we send it to vendors. And what we want to do here is do some vendor selection. Not every manufacturer is the right manufacturer for your product. So a lot of work needs to be done into reaching out, getting quotes, negotiating with vendors. Do you make it in the USA? Do you make it in China? Do you produce it in India? Make it out of Taiwan? Build a relationship and a partnership with the manufacturer, because at the end of the day, they need to have your back in case something does go wrong. And that's here in our ultimate product guide, like a single bullet point, but that is like a huge part of your intellectual property, or at least a trade secret that you need to have, is what vendor you use and what your relationship with them is. They can help you out tremendously. And of course, they want you to succeed because you will bring business back to them. And when you have picked out a vendor, you do some product samples. So you give them some money and be like, okay, give me your first shot at what you think this product needs to look like. And they'll give you some samples. You pay some money, you get some samples, and here things will become more clear. And we have now moved into the manufacturing section of the actual engineering design cycle. And if you did your due diligence, there will be very little surprises moving forward. If you didn't do your due diligence, you'll have a lot of manufacturing surprises. And at the end of the day, you're going to pay for it. And you're going to end up in one out of these three on the iron triangle between right, fast, and cheap. You could have done it fast and cheap. You'll be number 2, but it won't be right. Or if you did it right and fast, it won't be cheap. If you did it right and cheap, then it won't be fast. So everyone has the same constraints, and there is no shortcut to this. I know people, companies who've attempted to create shortcuts. By the end of the day, it will never work. There is always a minimum requirement for a product. The law of thermodynamics are still undefeated. So provisional patent, what is this kind of mean for you, and when should you start doing a provisional patent? We recommend doing a provisional patent once you have started the manufacturing process, or maybe even right before you've done the actual reaching out to manufacturers. And what a provisional patent does, granted by the U.S. Patent Office, these guys have something called a provisional patent by law, and a provisional patent is essentially a placeholder for your idea for an entire year. So the moment you submit your provisional patent, you're saying, hey, hold my spot here. This is the idea that I have. I'm not sure if I want to spend money and time on fully patenting it. Nevertheless, hold my spot, and this is kind of the idea that I have, and you want to explain to them what the idea is. And it gives you time to test the market for an entire year, make the product, sell it, market it, and see if it is going anywhere before you spend more time and effort on actually patenting it. It also allows you time to develop your product a little bit more, maybe refine it, adjust it, and gives you some flexibility. And now let's look here on card number 13. What are some of the elements of the provisional patent? Well, the first thing that happens is once you submit that, you become patent pending. Now, if you are forward looking and done your due diligence in the product design process, maybe patent pending is a sticker that you include in your bill of materials, so that the manufacturer, once it makes your product, every piece has a sticker that says patent pending on it in anticipation of submitting the provisional patent. So a provisional patent has provisional patent specifications. So that is a technical description of what is included in the idea and the product. And I should probably stop you and say this is for a utility patent, right? Not for a design patent or copywriting or trademarking, right? This is for a utility patent only. And so the provisional specifications is kind of a description of the idea. And once you submit that, you can't go back and edit it. Just because you can't say, oh, I came up with this idea a year ago, and then they go back and look at the documentation. It has nothing to do with what you're claiming you invented a year ago. So the description has to be set, and you need to do your due diligence in describing your product appropriately, and also make sure you give broad enough statements and room for further development of the product. If you're too specific, you can't go back on your words. If you're too broad, then it doesn't apply. It gets too vague. So you have to find that middle ground where it makes sense. And your provisional patent specifications really come from the product research that you did. So you're saying the product does X, Y, and Z. This is the product. This is the problem that this patent is solving. And that is where those come from. So if you haven't done a product research or a proper product research, it'll be hard to describe the value proposition of your patent. So this is one way the product research step kind of helps you forward looking, is not just helping you determine if you want to move forward, but it also helps you in the patenting process. So then a provisional patent needs provisional patent figures. I mean, it's not a requirement, but you really should. Most modern provisional patents have figures. And these figures are essentially drawings, sketches, 2D sketches, line drawings that describe what you are talking about. And if you have created a prototype or production CAD models and CAD drawings, you can directly tap into those and convert them into patent figures. So we here at Bevel Edge, when we're designing and creating drawings for a customer, we don't just do these drawings technically for production. We also have the provisional patent in mind. That way the customer or our client doesn't have to pay extra money and remake all these models and remake all these drawings for someone that does patent illustrations only. So our engineering drawings oftentimes serve as both the engineering drawings and also serve as provisional patent figures. Now there's a decent amount of work to like renumber them and edit them to meet the USPTO requirements, but nevertheless, half of the work is already done. And then provisional patent claims. So the provisional patent claims, I guess, are the bread and butter of like what you are actually claiming in your utility patent. And you know, if you have not done a patentability research, maybe your claims will infringe on an existing patent, or maybe your claims will be too specific. You also, want to make these as broad as possible so you can reduce your scope later. Nevertheless, if you've done your patentability search in the past, step number 4 of the product development cycle, if you've done those in step number 4, you should feel more confident or have better ammunition to make better decisions on how to craft your provisional patent claims. Now, these you want these to be broad, but you also don't want them to be too specific. So it's a fine line of adjusting these. You really can't go back in this provisional patent once it's submitted, and it's a balance. However, there are ways to overcome mistakes or specificness that you put in, or maybe you were too broad. Those are handled with other kinds of patent applications or add-ons to it. So we'll get into those later. And then the provisional patent, of course, is made out of a provisional patent application. That is just the application, the official submission to the USPTO. There's a process and some forms that need to be included. And once you get that email or receipt back, you are officially patent pending. Congratulations. And again, let's bring back that iron triangle. So if you look over here, your product research, your detailed CAD modeling, CAD drawings, and product design, and your patentability search, if you haven't done those, when you get to this stage, it will come and bite you, and you're going to have to pay for an attorney or another group to do your provisional patent from scratch. So it goes again to right and cheap is not going to be fast. Fast and right is not going to be cheap. And fast and cheap surely won't be right. So if you have proper foresight, which is something that this ultimate product development guide is trying to help you with, it'll help you put these things into perspective and allow you better to make decisions forward-looking and backward-looking, and allow you to move at risk when the risk is completely understood and known by you. Okay, provisional patent. Moving on. All right, congratulations. You are now patent pending. You have your patent together, and you're getting ready to expose your product to the world and start selling it. And this is bringing us to card number 14, which is marketing strategy. So basically what you want to have some kind of strategy moving forward into your sales. Let's quickly look at these. You want to have a product roadmap, right? What does that mean? You want to have a strategy for your product launch. You want to have a digital marketing strategy, and of course a social media marketing strategy. These days, this is kind of one of the best bangs for your buck. If you can figure out how to market your product in social media, you'll get a lot more out of it than just regular ads. Anyways, so going back to the engineering design book, they have provided an excellent figure 2.5, expanded view of production development cycle for us to look at. That way we can understand better what we're talking about. So as of now, we've been in the pre-market phase. So in the pre-market phase, all we've done is research and development, and we've done our market study and our market analysis. And this card number 14 is a marketing strategy. It is highlighted here in this green column. That is right before you start doing your sales. So you really want to have a strategy before you start selling. Otherwise, you'll launch your product and won't have any sales, and it'll just sit there. And no matter how much due diligence and how great your design is and how good you solve these problems, it won't necessarily translate into the dollars that you've expected. So speaking of dollars, let's look at the y-axis here, profits. So from the moment you start to reach out and spend your time and effort and money in developing this product, you are going to be in the red, naturally so, right? So you're spending all your money, time, and effort getting here, and you're mostly in the red, and the most you'll be in the red is right before product launch. And that just only makes sense. Now you've spent money on inventory and all that stuff is on the way. You've spent money on patents and designs and all those things. And now you want to go into sales. And that's where market strategy comes in, because it helps you strategize on how to increase your sales. And the sales The profits from the sales that you get will ultimately reverse this negative trends from being in the red to in the green. So that is going to be your break-even point. So all the money you have spent into the product development, you start breaking even fairly early on once you start making your sales. And then your profits will just increase, and then naturally the product will die. Now, you say to yourself right now, okay, what do you mean the product will die? Every product does. I mean, let's look here in the bottom left. This is a Windows 98, one of the most revolutionary computers ever created, a personal computer. And guess what? This product is dead. It doesn't mean it was a bad product. It's just all products come to an end. And if you have a product roadmap, the product roadmap will help you anticipate when this decline in profitability comes in. And it allows you to potentially sell the business when it's still profitable, or sell the product idea when it's profitable to a bigger company, a bigger firm. And you just need to know when that time is, right? You don't want to sell too early, then you're missing out on profits, but you want to sell at the right time. And going back to the actual proper design documentations, engineering analyses, and the patents that you've submitted will all become in scrutiny when you're trying to evaluate the value of your product. So it is important that it is done properly with due diligence, so it will just increase your value. So now you're in the market phase, and so the market phase bullet points are right here: product launch, the product introduction, right, number 9, and all the way to abandonment of the product, right? And you want to be able to predict the decline, the maturity, and then once your patent runs out, the market will become competitive. So all of these things you need to kind of be account for, and that essentially happens with your product roadmap and having a strategy there. So let's look into each one of these points here. A sub point of, let me go back here, digital marketing. So we have card number 14, but card number 15 is kind of a subgroup of digital marketing and like how you want to do that. And these are like some of the more important things you want to do when you are launching your product for the first time. We just thought this deserves to be its own card, since there are some do's and don'ts here and some forward-looking you want to do in this scenario. Okay, product web page. Obviously, when you're launching your product, you need a website. All that is part of digital marketing. You're going to be selling on Amazon, Temu, eBay, Walmart, Etsy, Shopify, your own store, right? Or you'll be selling it to resellers. So all these things can be done through a web page or a specific funnel that clients will come into and essentially swipe their credit card and give you money. So what are some of the things you need on your product web page? Obviously, you need a GTIN, and a SKU. So these are universal numbers / barcodes that will identify your product. So you want these actually labeled on your product label, on your product packaging. If you didn't think you needed those things, think again. Those are going to be valuable. They'll differentiate you from all the other ones. So I think the GTN stands for Global Trade Identification Number. So in the entire globe, your product will have this unique number. And then your SKU is your stock something ID. So each product will have a SKU as well. So you need to make sure you have both of these. And then your product web page needs to have product images. So now think about this: you do all this due diligence and design a cool product, and the pictures aren't up to par. And at the end of the day, the clients or your customers who are buying the product, their first impression is just going to be from the product images. So you want to make sure the product images that you have are proper and professional and give the customer the right idea. Product video, if you have a more complicated product or you want to highlight the pros and cons of why you should buy your product, you definitely need a professional video. And also a decent product description, which is key. And honestly, most of these web pages, so an Amazon sales page, an eBay web page, or Etsy shop, they'll push you to give these to them to begin with. And if you can do this professionally, and if you can think ahead, then you can be prepared for these. Most of these can actually be done with a manufacturer sample that you get from a previous step. Now you're asking yourself, what are some of the things we should be highlighting? And the answers are in your provisional patent. So go and look back in your provisional patent and see what are the key things that make your product different, worth patenting it, right? So that should be the kind of information that you want to highlight in your product images and your product videos and description. And then some of the stuff you've done during product research will tell you how to advertise these things. So these are the things you need to advertise, and this will tell you how. Again, if you are marketing to, let's say, teenage boys, maybe the marketing needs to look completely different. If you're marketing to moms of 3+ children, or to grannies, right? And the demographic, age, and all of that will become more clear once you've done your product research at the very beginning. Step number 3, really, and that's how step number 3 actually ties directly back into your product launch and your web page. So what colors do you want to use, right? Are you going to use pink and red, or are you going to use red and blue? So those decisions when it comes to designing your web page will come from your product research. And if you didn't do those, you're going to scramble or have a subpar product launch. All right, moving on to step 16, actual intellectual property development. So disclaimer here, this is not legal advice. You should seek professional counsel for actually developing your intellectual property. So Bevel Edge, we actually do not help with this. We just help connect our clients to the proper attorneys who are have worked with us in the past, know what to expect, and be able to put our clients in the best situation moving forward. Now, when do you want to move towards intellectual property development? And let's look at this card number 16 again. I'm going to read those out. You want to have a non-provisional patent application, and that is an official utility patent application. So the provisional one was just a placeholder, and this is actually like a serious one where it's going to get examined and scrutinized by the U.S. Patent Office examiners. And then maybe you want to do some continuation in part patents. Continuation in parts are additional things that you have created or invented as you iterated on your product, or new things that you've discovered. So a lot of times the continuation part will get the priority date of your provisional patent or your non-provisional application, but anything new that wasn't discussed in the previous matter will have a new starting date. So those are kind of cheap ways to iterate and expand your patent portfolio. Patent portfolio will essentially make your product more valuable when you want to go sell it and have an exit strategy. And then naturally also design patents. Design patents are things you'll come up with that give your product a unique look. I think the U.S. Patent Office has a specific description for design patents, but it's a patent application that protects the looks of a product. And then naturally trademark. So usually I help my clients set up their trademarks right away as soon as they have their website to protect their logo or their brand logo or their brand name. That's fairly easy done. We help our clients get their trademarks together. At the end of the day, you want to get proper legal counsel for that as well. And I'll have some more tidbits for the trademark. Now, I have seen scenarios where clients come to me and they say, hey, I have a patent. Here's my patent. Now make the product, design the product for me because I have a patent and my patent is protected. And what they did not do when they created that patent is they did not go through these product development stages. So they didn't do a product research. They didn't have a proper prototype design. Maybe the prototype design didn't take into account manufacturing, or they didn't properly test and evaluated the design that they had, and they didn't have detailed production ready design documents. Obviously not. And the design wasn't scrutinized for manufacturability. They never did a provisional patent either, or actually tested the market to see if the design that they have is marketable and profitable and sells. So they go straight to the intellectual property and start fully patenting it. And they come back to me and they say, hey, Ollie, design me something now based off this patent. While that certainly can be done, it will most likely be different than the requirements in the patent. And, they inevitably have to file another patent. Or it will become too expensive and not realistic to manufacture, or it doesn't meet customer requirements. It just makes for a subpar strategy or approach. So you usually want to start your full utility patents and your intellectual property development about 6 months to a year into launching your product or launching your business, right? That way, this stuff has actual true value and meaning. And a lot of times you have patents that just sit there. And if you go look into the U.S. Patent Office, a lot of these patents are not like on the market. They're just hanging out and belong to someone in someone's name. And they don't do anything. So that's why the Ultimate Product Guide suggests that actual full patent development and intellectual property development should be done as step 16, and that's why we recommend it. Now let's look at this. I want a tidbit here for trademark. So a provisional patent, or a non-provisional patent, expires after 20 years. The U.S. Patent Office says we'll let you have the rights and full authority over who or what can sell this product. That way you can have decent profits for 20 years, essentially guaranteed profits. So that's encouraging people to innovate and come up with new patents. And continuation parts as well, and design patents expire after 15 years. However, trademarks do not have an expiration date. Trademarks exist to identify the business or the company. So as long as a company exists, the trademark is in effect. Now, I was doing some Googling and I found this cool knife. And if this knife company, NRS, did a patent on this mechanism to retract, and it's a pretty cool mechanism, right, to retract and expand their knife, this patent will expire after 20 years, and now I can potentially start copying it and selling it and make use of this cool system that they've created, this design that they've created. Now, if NRS was clever, they would have created a trademark in this shape right here. So essentially, you really can't recreate this knife unless you have this particular shape down here. And what they do is they say, hey, any knife that's this shaped, or any shape such as this, is part of our company's existence. And if you create a knife similar to it, no matter if the patent, provisional patent, design patent, or the continuation part patent is expired, you are infringing on our existence. So that's almost like copying a Ford logo or a Toyota logo and slapping it on a car and saying, we're Ford now. You know, that's just not going to happen, because that's the identity of that company. So one of the most clever things you can do is essentially trademark the utility and the function of your product, and have it protected as such. That way, no matter if your product patents expire, you are still protected through just the pure existence and identification of this shape with your brand name. So that's probably the ultimate protection, highest level of protection that never expires. So that's very tricky to do and doesn't happen all the time. You really need a good attorney that can help you put together some solid trademarks, maybe in plural, to make this happen. Okay, so that is how we recommend that our clients develop their intellectual property. Okay, and as the final step, step number 17, card number 17, is going to be design support. So how do we support the product and create new products out of it? Engineering design has a decent graph that they show us here in the bottom. Let's take a look at that one first before we get into some of the details. So any technology that you create, so the patent is a patent and it's just a concept, right? That's why we have this highlighted here. It's just a patent. It's just a concept that doesn't tell you how to make it, unless it's a patent specifically about the manufacturing of it. This just captures the utility that you bring. And what happens is a given technology that you create kind of with a little bit of effort will increase performance drastically. So that is kind of your idea. It's revolutionizing. It's creating a new performance metric that exists. And eventually it will die off and taper, and the product won't be any better. And it will just stay there, and maybe your profits will start to die. Now, with that given patent that you already have, you can start to create new technologies. So technology A, technology B. Consider these technology A and technology B different design documents, right? A design package essentially, right? So these are new technologies that you're creating based off of one patent or multiple patents combined to make a given technology. What you will do is, as you see that one of your products is dying down, or is losing its hype, or it's reached its performance peak, you will iterate on the design and create technology B, and with a slight bit of effort, increase the quality of your product, or a new version of a product that has a better performance or much higher performance. And then that can also eventually repeat to technology C. And one of the good examples here is maybe car manufacturers, or again, Yeti. So let's say Yeti has a patent on a specific cooler design, right? They use a specific styrofoam or some kind of vacuum sealing formula that creates an ultimate and super high enduring cooler. With that patent, they've created this technology here, the Tundra cooler, and then they create the Rhodey cooler. I mean, they're the same thing, just different configurations, different technologies off the same patent. And then Chandra Hall, another cooler, or maybe some custom designs, right? Or the Yeti tank. These can all use the same patent. And then conversely, the hopper flip was something that they developed on the side. Maybe it's not using the exact same patent here, and they've created another patent, a second patent for the hopper flip. And with that, they can create multiple technologies. The hopper backflip, right? The hopper 2, right? The camel carry. So you see that one patent can branch out into multiple different technologies, or maybe they just turn it into a backpack, right? So these are different designs that are working off of the same patent. So goes back to card number 17, which is design support, continued design support for the product lifecycle. So, you want to create different product variants, different families of products. Maybe you have a boy version, a girl version, a back to school version, a New Year's version. So all of those things need to be supported, and a lot of times these are supported by engineer or through design. The lift is relatively small compared to original product development, but nevertheless, these have to be supported by some kind of design. When you have a new idea, you want to be someone that are supported. Maybe different shoe sizes, right? You have the same shoe, same concept, same design, but you want to create variable sizes. Maybe you have an indoor shoe, outdoor shoe, cleats and spikes at the bottom, super slick, right? Anyways, different materials. Maybe some is leather, some is that plastic. So different product variations need to have some kind of design support, and that's kind of what we're highlighting here. And then engineering change notices. I'll probably make an entire video dedicated just to that. Engineering change notices are like essentially finding mistakes in the official design documentation that you've created, and how to go about officially communicating these engineering changes to your vendors, potentially your customers, and how to manage these in inventory. So hopefully you've never have to do these. If you've done due diligence, that won't happen. But sometimes mistakes seep through, and that's how we do an engineering change. And then finally, maybe doing an official registration for your patent. Now, let's say you've designed a kid's toy, and there is a governing body that says, hey, every kid's toy that's created in the United States needs to be registered with us. Or you create some kind of food adjacent product, or some kind of medical device that needs to have Food and Drug Administration registration. Now you're kicking off the official registration process of your given product. And if you did not keep this in mind right here, you might be forced to go back and redo all of the documentation you've created. Every design document, every test that you've done, you might have to retest these based off of the official registration requirements. So I know this is just kind of like a bullet point at the very end, but this is kind of very critical and something that you have to recognize very, very early on, which goes back to the product research that we actually suggest you to do. So that way, when you get to registration, maybe you've done some of the work up front, and all you have to do is package it together. But anyways, this is the last slide here of the Ultimate Product Guide. And let's go back to the very beginning again and take a look. So we've taken you from the actual idea, conception, to product research, patentability search, conceptual design, prototype design, test campaign, actual final production design version of your design and your idea or your product, split into two. So product design package and product design documents, finding vendors and getting some samples, starting the provisional patent for you, putting together a actual marketing strategy on how to launch your product, and then some of the requirements your websites need to have. These are kind of listed out here. There's some pitfalls that you want to avoid, or maybe some things to be mindful of and cognizant of ahead of time. And then a strategy to develop your intellectual property and make sure that the value of the product, not just the amount of money that it brings, the quality of it, the customers that it has, is also backed up by the design documents that you've created, the technology you've created, and also the intellectual property you've created, and some of the strategies that you should implement. And then lastly, as we just spoke about, the continued design support in an effort to continually improve your product, make different versions, capture more market, capture other customers with different requirements that fall under the same wheelhouse as the product you've developed. And ideally, if you've done your job right, number 17 should be pretty easy to do. Anyways, this is the ultimate product development guide, and it's a PDF version downloadable on our website, thebeveledge.com. So go over there, download it, keep it as a reference. This is 100% for free, and we truly believe that if our clients are educated and understand this product roadmap, inevitably it will help them succeed, and their success is a reflection of our success. Anyways, thank you very much. Thanks for listening, and talk to you soon.